What are the key building codes for mechanical HVAC design? Have you ever wondered what rules and regulations guide the design of heating, ventilation, and air conditioning systems? Understanding the key building codes for mechanical HVAC design is essential for creating safe and efficient systems. Let's break down the important codes that every mechanical engineer should know. First up are the International Residential Code and the International Building Code. These codes set the foundation for residential and commercial buildings. They cover everything from HVAC load calculations to duct sizing and equipment installation. For instance, the International Residential Code requires that HVAC load calculations follow the Air Conditioning Contractors of America Manual J4 proper sizing. Duct sizes must align with these calculations or be adjusted accordingly if different sizes are used. Next, we have the American Society of Heating, Refrigerating and Air Conditioning Engineers Standards. The American Society of Heating, Refrigerating and Air Conditioning Engineers Standard 90.1 is crucial for energy efficiency in HVAC systems. It sets minimum efficiency levels for heating, cooling, and ventilation. Additionally, the American Society of Heating, Refrigerating and Air Conditioning Engineers Standard 183 provides guidelines for determining heating and cooling loads, which are vital for proper system sizing. The International Energy Conservation Code is another important code that focuses on energy conservation. It requires HVAC systems to meet specific efficiency and performance criteria. This code often works alongside the American Society of Heating, Refrigerating and Air Conditioning Engineers Standards and includes requirements for fan efficacy and duct insulation. It also mandates that load calculations and energy compliance documentation be submitted during the permitting process. The Uniform Mechanical Code and the National Electrical Code are also essential. The Uniform Mechanical Code governs the mechanical aspects of HVAC installation, ensuring safety and proper equipment clearances. Meanwhile, the National Electrical Code addresses electrical safety for HVAC equipment, covering wiring and grounding. Ventilation and indoor air quality requirements are critical as well. Codes requiring mechanical ventilation in buildings with low air infiltration rates to ensure a fresh air supply and control indoor pollutants. Ventilation rates must comply with specified airflow rates to balance energy use and air quality. For practical applications, mechanical engineers must perform accurate load calculations using recognized manuals to size equipment and ducts correctly. They also need to ensure compliance with local amendments to national codes, which may include climate-specific design temperatures. Documentation such as load calculations and energy compliance reports must be prepared for permitting. Selecting the right equipment and designing systems to meet energy use limits helps comply with energy codes and reduces operational costs. Coordination with electrical and mechanical codes ensures safe installation. In summary, understanding the key building codes for mechanical HVAC design is vital for creating systems that are safe, efficient, and comfortable. Familiarity with the International Residential Code, International Building Code, American Society of Heating, Refrigerating and Air Conditioning Engineers Standards, International Energy Conservation Code, Uniform Mechanical Code, and National Electrical Code is essential for success in this field.